What's going on, guys? Welcome back. Moving on to the next question, we have to write two ways to restrict the domain of this function f of x equals negative x plus 2 squared plus 3 such that the inverse, or f of negative 1x, will be a function. Okay, so we've done these types of questions before, even back in Unit 1, but we haven't really done it in two ways. So what I'm going to do is I'm first graph this function here. Now notice this is a parabola in vertex form, and the vertex is negative 2 and 3. So f of x, I'm going to graph it, and I'm going to do so with a table of values. Now, you don't necessarily have to make a table of values. I'll actually explain at the end of the video how you can do this a little bit faster without making a table of values and making it look all nice, but let's do it the long way first, and then I'll explain the short way. So, making a table of values, we've got the vertex. We want our function to be nice and symmetrical, so the vertex is going to go in the middle. And then I'm going to pick two x values to the left of negative 2, so let's say negative 3, negative 4, and then to the right of it, so negative 1 and 0. So if I plug in negative 4 into the function, negative 4 plus 2 is negative 2 squared. That gives us 4. Times negative 1 is negative 4 plus 3, that gives us negative 1. If I plug in negative 3 here, negative 3 plus 2 is negative 1, squared is 1, times negative 1, so negative 1 plus 3, that gives us 2. And then if I plug in negative 1 here, that will give us positive 1, squared, times negative 1 plus 3, that gives us 2 again. And then if I plug in 0 for x, that will give us 4, negative 4 plus 3, that gives us negative 1. So notice how it's nice and symmetrical. So if I take this and I graph it, so 1, 2, 3, 4, let's say, then 1, 2, 3, 1, 2, 3. I think that's all we need. Negative 4 and negative 1, that's down here. Negative 3 and positive 2, that is up here. And then negative 2 and positive 3, that is up here. Negative 1 and 2, that's over here. And then 0, negative 1, that's right there. Right? So this parabola looks something like that. Right? Where that vertex is negative 2 and 3, like that. Right? So this represents f of x. Now, what's the domain here? And the range. Well, the domain here is XER. Basically, x can be any real number. It's always what it is for a parabola, unless you're dealing with a word problem, which we are not dealing with here. Then the range is always YER, but it depends on that vertex and whether the parabola opens up or down. It's opening down. The y value of the vertex is 3, so all the y values have to be less than 3. So y is less than or equal to 3. Right? And now let's graph the inverse. So the inverse, because we have the table for the function, we could just take all these points and switch them, right? Interchange them. So negative 4, negative 1, that would change into negative 1, negative 4. Then we'd have 2, negative 3. We'd have 3, negative 2. We'd have 2 and negative 1. Then we'd have negative 1 and 0. And then we could just plot these, right? So as we know, the inverse of a quadratic is going to be what? It's going to be a sideways parabola. So if I take this, graph it, so I'll have 1, 2, 3, 4, then negative 1, then I'll have 1, 2, 3, 4. So x negative 1, y value negative 4, that is down here. 2 and negative 3, that's over here. 3 and negative 2, that's over there. And then 2 and negative 1, that's going to be over here. And then negative 1 and 0, that's right there. right? So notice that's a sideways parabola here. So like that. Right, so the domain and range of this is what? Well, it's actually going to be just interchanged from this. So the domain, notice all the x values in this case have to be less than or equal to 3. And the range, the y values, can be anything. Right, because this just keeps going up and down until infinity. So notice the relation between the domain and range here. It's just interchanged. Okay, so from here, what they want is they want you to restrict this domain so the inverse is a function. Notice right now, this inverse is not a function because it's failing the vertical line test everywhere. Right? It touches the vertical line at 2 points, if you remember from Unit 1. So how can we restrict perhaps the range in the inverse for it to be a function? Well, what if we take out half of that sideways parabola? So we take out this portion, so we're just left with this positive portion here. Well, notice that this vertex here is happening at 3 and -2. So this y value is -2. So if we can say that all of the y values have to be greater than -2, that would take out the bottom portion there. So let's restrict the range and say that y has to be greater than or equal to -2. Right? Because then this would go away and we would have a function, because this remaining portion, that's almost like a square root function, right? It would pass the vertical line test everywhere. So if we restrict the range in the inverse, we have to restrict the domain in the original function. So when we say y has to be greater than or equal to -2, that means x in the function has to be greater than or equal to -2. And what that means is we're pretty much getting rid of this. So we're just left with this half, and this half, the inverse of just that half, is this half over here. So that is one answer. That's one way to restrict the domain. So the inverse would be a function because, again, that bottom portion wouldn't be there, and then the remaining portion would pass the vertical line test. Okay, another way we can do it is we can take away the top portion. So we could have this bottom portion instead. So if we take away the top portion, basically we would say all the y values have to be less than or equal to -2. Right? Because then top portion's gone. We're just left with this bottom portion, and that passes the vertical line test. So then the inverse is a function. And if we restrict the range of the inverse, being y has to be less than or equal to -2, that means x has to be less than or equal to -2 for the function. So we would just be dealing with this left half of the parabola. This would go away. Right? So those are the two ways to restrict the domain for the function. So for f of x, so the inverse is a function. Right? We can say x has to be greater than or equal to -2, or x has to be less than or equal to -2. Right? So that is how you do that. That's how you do it visually. Now, you didn't really have to make this table of values here. If I got this question, I would just do it a lot quicker. What I would do is I would just care about the vertex. So I know the vertex is happening at -2 and 3, which is around here. And I know this is opening down. So I would just draw a parabola that's opening down like this. And then from this rough sketch, I can get the domain and range, right, for the function. And then I know the domain and range for the inverse is just going to be switched over, right? So because all the y values are less than 3, I know all of the x values are going to be less than 3 for the inverse. Right, so if this is 3 here, and then the vertex is -2 and 3 for the function, so that means the vertex for the inverse is going to be 3 and -2. So that would be down here. All of the x values have to be less than +3, so I know it's going to look something like that. And then from here, we can just do what we were doing visually. We could restrict this part, right? So all the y values have to be less than 2. that means all of the, less than -2, that means all of the x values have to be less than -2. Or all of the y values have to be greater than -2, which means all of the x values have to be greater than -2 for the function. Right? So you don't have to make a table. I just did it so you can see how the inverse looks a little bit more specifically. But if you're pretty comfortable with parabolas at this point, all you need for a parabola and its inverse is the vertex and whether it opens up or down. Then you could get the domain and range, and then you can just switch that. That's going to be the domain and range for the inverse, and you can create a rough drawing and then just go from there. But either way, if you're not comfortable doing it like that, doing it quicker, then I'd recommend doing it the long way, making a table of values for the function, making sure the vertex is in the middle, switching the points, graphing the points for the inverse, and then from there you could see how to restrict the domain for the function so the inverse is a function.